Hello everyone. Today we'll be talking about the different chips that we use in our initium product line. So we have three different chip types. We have B chips, C chips, and E chips. The letters correspond to the maximum pressure that each chip can withstand, and it goes by increasing numbers. So the B chip has the lowest maximum pressure it can withstand, while the E chip has the highest maximum pressure it can withstand. So here are the maximum pressures that each chip type can withstand. We have 40,000 pascals for the B chip, 200,000 pascals for the C chip, and 1.6 million pascals for the E chip. The numbers on the side of these letters, so VO5, CO5, EO2, correspond to the two different channel depths that we have in the initium product line. So O5 corresponds to a 50 micrometer channel depth, while EO2 or O2 corresponds to a 20 micrometer channel depth. And these channel depths, in conjunction with the maximum pressure that the chip can withstand, dictate which shear rates that you can explore while using your specific chips. So VO5 and the CO5 chips, depending on the maximum pressure as well as the viscosity of your sample, have a shear rate range from 40 to 20,000 inverse seconds, while the EO2 chip has a shear rate range between 250 to 125,000 inverse seconds. And so finally, the combination of the maximum pressure that the chips can withstand, as well as the shear rates, which are dictated primarily through the channel depth, can tell you which viscosities your sample can be, and while still being measured on each specific chip. So the VO5 chip range is between 0.2 to 2,375 centipoise or millipascal seconds. It's the same unit. The CO5 chips have a range between 0.8 to 10,000 centipoise, while the EO2 chips have a range between 0.5 to 250 centipoise. This star indicates that more advanced users can potentially explore higher viscosities, but for the full capabilities of the initium instrument, 250 is the limit. We can walk through that maybe in a future video, how you could explore higher viscosity samples. So as you can see through all this information here, that there are pluses and minuses for each chip type. So if you are looking at primarily low viscosity samples, then maybe B chip is the way to go, while if you have a higher viscosity sample, C chip is the way to go. As for the EO2 chip, if you suspect that at high shear rates that your samples are going to be non-Newtonian in nature, then maybe the C chip or the E chip will be the chip of your preference. So this might lead you to wonder, well, how can I tell which chip I'm using? Well, on the front of the outside casing of the chip, we have a chip serial number. So right here, I have three example serial numbers for the three chip types. The first number, the 19 in this case, corresponds to the year that the chip was manufactured. The I corresponds to the instrument that you're using. So the I corresponds to initium chips, but we also have microvisc chips and VROC chips. While the microfluidic device is the same throughout all chips, the external housing is all different. And so to know which type of chip you're using, you also have this lever. And then to see which chip you're actually using, in the middle, we have VO5, CO5, EO2 to dictate to you which chip you're using. And finally, the last three digits of the serial number are the number, it's the chip number of its manufacturer. So here for the EO2 chip, this 9 means that this EO2 chip was the 9th EO2 chip manufactured in 2019. This means as the 536th C chip manufactured in 2019. And this number denotes that this B chip was the 258th B chip manufactured in 2019. So hopefully that answers some of your questions about the different chip types used on the initium. And in a future video, we'll go over the specifics of the chips. We'll crack one open and show you the internal workings of the chip. And thank you for watching.